Dear friends, I am Dr. Santosh Desai and I welcome you all to my YouTube channel Desai's GATE Engineering Mathematics. Today we are going to discuss some concepts from linear algebra. In this video, we will discuss matrix, algebra of matrices. It contains equality of matrices, addition of matrices, scalar multiplication, multiplication of matrices, and we conclude this video with transpose of matrix and properties. We begin with definition of matrix. An arrangement of mn numbers in m horizontal lines and n vertical lines, and the arrangement being enclosed by square bracket or round bracket is called a matrix of order m by n. Here we note that horizontal lines are also called rows and vertical lines are called columns. Now we consider examples. In the first example, 9 numbers are arranged in 3 rows and 3 columns. So therefore, it is a matrix of order 3 by 3. In second example, 6 alphabets are arranged in 2 rows and 3 columns. So therefore, it is a matrix of order 2 by 3. In third example, 6 numbers are arranged in 3 rows and 2 columns. So therefore, it is a matrix of order 3 by 2. Now, we define general and compact form of the matrix. General matrix of order m by n, that is matrix having m rows and n columns, is given by capital A is equal to first row is A11, A12, A13 and so on A1n. Second row is A21, A22, A23 and so on A2n. Third row is A31, A32, A33 and so on A3n. Continuing in this way, last row of the matrix is AM1, AM2, AM3 and so on AMN. Here, each element has two suffixes. The first suffix indicates the row and second suffix indicates column in which the element lies. Thus, A32 is the element lying in third row and second column. Now we define compact form of this matrix. Here we observe that all the elements are given in the form of Aij. So therefore we take capital A is equal to Aij. Now to find the values of I and j, let us consider first all columns. In all columns, just we observe first suffix. The first suffix runs from 1 to m. So therefore, I takes the values 1, 2, 3 and so on up to m. Now to find the values of j, now let us observe all the rows and second suffix of each element, and the second suffix runs from 1 to n. So therefore, j takes the values 1, 2, 3 and so on n. So therefore, the compact form of the matrix of order m by n is given by capital A is equal to Aij, where I runs from 1, 2, 3 and so on up to m, and j takes the values 1, 2, 3 and so on up to n. Now we consider algebra of matrices. Under this, first we define equal matrices. Two matrices, capital A is equal to Aij of order m by n and capital B is equal to Bij of order p by q, are said to be equal if they are of same order, that is m is equal to p and n is equal to q. And second condition, corresponding elements are equal, that is Aij is equal to Bij for all I and j. Now consider one example. Let A and B be the two matrices of order 2 by 2. Then A is equal to B if the corresponding elements are equal, that is A is equal to E, B is equal to F, C is equal to G, and D is equal to H. Now we consider addition of matrices. If A and B are two matrices of same order, then the addition of A and B is denoted by A plus B and is obtained by adding corresponding elements of A and B. Here we note that the order of new matrix is same as that of A and B. That is, if A and B are the matrices of order 3 by 3, then the A plus B is also a matrix of order 3 by 3. If A and B be two matrices of same order, then subtraction is denoted by A minus B and is obtained by subtracting corresponding elements of A and B. Now consider one example. If A is equal to 1, 4, 3, 2 and B is equal to minus 3, 4, 2, 5, then A plus B is obtained by adding corresponding elements and A minus B is obtained by subtracting elements of B from A. Now we consider properties of matrix addition. Let A, B and C be the matrices of order m by n. Then A plus B is equal to B plus A. That is, matrix addition is commutative. A plus in bracket B plus C is equal to in bracket A plus B plus C. That is, matrix addition is associative. If A plus B is equal to A plus C, then this gives B is equal to C. It is called left cancellation law. Similarly, if B plus A is equal to C plus A, this gives B is equal to C and it is called right cancellation law. Now we consider scalar multiplication. If K is a scalar and A is the matrix, then the matrix K into A or A into K is obtained by multiplying each element of A by the scalar K. Now for this, let us consider one example. Let A be a matrix of order 3 by 3. Then to obtain 5A, we have to multiply each element of A by 5. So thus 5A is equal to first row is obtained by multiplying first row of A by 5. So thus first row is 10, 15, 25. Second row is minus 5, 0, 30. And third row is 15, 10. Now we define matrix multiplication. This is a very important concept from the examination point of view. The product of two matrices A and B, that is AB, exists if number of columns in A is equal to number of rows in B, that is inner dimensions are equal, and order of AB is equal to number of rows in A by number of columns in B, that is outer dimensions of the matrices A and B. Now for this, let us consider one example. Let A be a matrix of order 3 by 4 and B is the matrix of order 4 by 2. Here, number of columns in A is equal to number of rows in B. So therefore, AB exists and order of AB is 3 by 2. The same can be explained in the following way also. A is a matrix of order 3 by 4. B is a matrix of order 4 by 2. Then to check whether AB exists or not, let us write AB and orders in front of them. Now you check inner dimensions 4, 4. These are equal. So this implies that AB exists. And again the outer dimensions are 3, 2. This is the order of AB. So hence order of AB is 3 by 2. Now, here question is what is about BA? That you have to think about whether BA exists or not. If it exists, what is the order of BA? Now we will see how the actual multiplication can be taken of two matrices. Let A is equal to Aij be a matrix of order m by p and B is equal to Bij be a matrix of order p by n. Then the product AB of these matrices is of order m by n and is obtained as AB is equal to Cij, where Cij are the elements of AB and the Cij's are given by Cij is equal to summation k is equal to 1 to p aik into bkj. Now if you substitute the values of k from 1 to p, then we get ai1 b1j plus ai2 b2j plus and so on plus aip bpj. Now we consider one example to take the actual product of two matrices. Let A be a matrix of order 2 by 3, B be a matrix of order 3 by 2. Here AB exists and the order of AB is 2 by 2. So therefore AB is equal to, first we write the matrices A and B. Since the order of AB is 2 by 2, its resultant will be C11, C12, C21, C22. Now the question is how to obtain these elements C11, C12, C21, C22. Now one can obtain these elements by putting the corresponding values of ij in the formula Cij and allows to vary k from 1 to 3. Or alternatively, one can find the product as, to find the product, let us consider the first row of the matrix A and first column of the matrix B. Multiply the corresponding elements and add these multiplications. We will get the first element C11 of the matrix AB. That is, C11 is obtained as, first you take multiplication of A11 into B11 plus A12 into B21 plus A13 into B31. So this is the value of C11. Now to obtain the C12, now we fix again first row as it is and consider second column of the matrix P, and again we take multiplications of corresponding elements and add all these multiplications. So thus we get A11 B12 plus A12 B22 plus A13 B32. Similarly, one can obtain the elements C21 and C22. Now for C21, consider second row of matrix A and first column of matrix B and multiply corresponding elements and add all the multiplications. So thus we get A21 B11 plus A22 B21 plus A23 B31, and the element C22 is obtained by multiplying corresponding elements of second row of A and second column of B. So thus we get A21 B12 plus A22 B22 plus A23 B32. So this is the multiplication of the matrices A and B. You can extend this idea for any order of A and B where product of A and B exists. Now we consider properties of matrix multiplications. Let A, B and C be any three matrices such that they are conformable for product. That is, all the products of A, B, C exist. Then A into BC is equal to AB into C. That is, matrix multiplication is associative. Second property, AB is not equal to BA. That is, matrix multiplication is not commutative. A into bracket B plus C is equal to AB plus AC, and in bracket A plus B into C is equal to AC plus BC. That is, matrix multiplication is distributive. Now, if AB is equal to 0 matrix, then it is not necessary that A is equal to 0 or B is equal to 0 or both A and B equal to 0. Now for this, let us consider one example. Let A, B be the two matrices of order 2 by 2. Now one can check that AB is equal to 0, but here all the elements are not 0, so therefore A is not equal to 0 and B is also not equal to 0. Now cancellation law does not holds. AB is equal to AC does not imply B is equal to C, and BA is equal to CA also not implies B is equal to C. For this, let us consider three matrices A, B and C of order 2 by 2. One can easily check that AB is equal to AC is equal to 0 matrix, that is 0 matrix of order 2 by 2. But here B is not equal to C. Hence, cancellation law not holds under multiplications. But if the matrix A is non-singular, that is, determinant of A is not equal to 0, then above law holds. If A is a square matrix of order n, then the powers of A, that is, A square is equal to A into A cube is equal to A into A, and so on. And now finally, we consider transpose of matrix and its properties. Transpose of matrix. A matrix obtained by interchanging rows and columns is called transpose of the matrix. For the notation purpose, if A is a matrix, then transpose is denoted by A raised to T or A prime or A dash. Here we note that if A is of order m by n, then A transpose is of order n by m. Let us consider one example. If A is a matrix of order 3 by 2, then A transpose is a matrix of order 2 by 3, which is obtained by writing first column as first row and second column as second row. Now consider the properties. If A and B are matrices and A transpose B transpose are transpose of A and B respectively, then A plus B transpose is equal to A transpose plus B transpose, and A minus B transpose is equal to A transpose minus B transpose. AB transpose is equal to B transpose into A transpose. This is a very important property. Next, A raised to n transpose is equal to A transpose raised to n, where n is positive integer. K A transpose is equal to K into A transpose, where K is scalar, and A transpose transpose is equal to original matrix A. Now, in the next video, we will discuss examples from previous year GATE question papers. For more videos, please subscribe my YouTube channel Desai's GATE Engineering Mathematics. Thanks for watching. Bye bye.